Welcome to bestia.dev. Learning Rust and Wasm programming and having fun. I just love programming. In my 5th tutorial of the series, Bestia.dev Tutorials for Rust Programming Language, I created a simple web application, web page hit counter. It works fine on my local Rust development environment inside a Docker container. Now I want to deploy it to the cloud. The code for deploy is part of the web page hit counter project. I have one VM engine on Google Cloud. It is really small, but unbeatably cheap, free tier. Services included in the free tier US West 1B, Oregon, Compute Engine E2 Micro Core, before discount €3.85. E2 RAM, before discount €2.06. Total €0. I access the VM over SSH from my WSL Debian Bash terminal. Then it opens the Linux Bash terminal of the VM where I manage everything. No GUI needed. It is just a server. I will uninstall Docker, because I will use Podman instead. Podman is an in-place replacement for Docker. It is not a service, just a simple executable. On my VM I didn't really use any containers before. I was just experimenting with Docker, so I don't care if I delete everything. Images, containers, volumes. Installing Podman is super easy on Debian 11. Pull and run the Postgres container. For now we will not deep dive into security. We will do that later. We need a local directory to persist the data of the Postgres server. It is not good to have the data inside the container. Then the data will be deleted if the container is removed. And that will happen eventually. Containers are ephemeral. They can be deleted at any time. I will install the PSQL utility to work with the Postgres server. I will back up the database on my development Postgres server and restore it on the VM. This is a skill every database developer must know. In the VS Code terminal of the project webpage hit counter run this commands. Now on the VM server I need to restore it. In psql the \l command lists the databases. Use \q to end or quit inside PSQL. Every SQL statement must end with semicolon. Excellent. We will not use this Postgres container. It was only for testing. We will create a new pod with a new container. We can remove this container now. The data will persist on the system disk. I have many small and simple web applications on my Google VM. Now that I have Podman installed, I will put the webpage hit counter application in a container. I want to isolate the applications. From my Rust development container I will upload a few files to my Google VM folder. I will create the container image with builda. This is the Podman utility for creating images. The binary executable file and the .env file must be in the same directory where the bash script is run. Note that the size of the binary can vary enormously. In build debug mode it is 135 megabytes, in build release mode is 10 megabytes. On that I use the strip command and it is now 5 megabytes in size. I upload files to my Google VM using rsync and SSH. I coded this in the automation task cargo auto published to web of the project webpage hit counter. We can now connect the terminal to my Google VM bash over SSH. Run the bash script to create the image. Now create and run the pod. This will also run the web app. Check the Postgres server with psql. List the databases with \l. End the list with \q. Run the SQL select statement for the table's webpage and hit counter. The bash script already started the web application in detached mode. We can see the standard output with Podman logs. The application listens to port 8080, but this port is already in use on my Google VM. Containers can easily forward ports, so we can easily change the port to 8011. It works. Repetition is the mother of learning. Now that everything is configured it is very easy to deploy any web server plus database application. In VS Code terminal of project webpage hit counter. Build a new release cargo auto release. Publish to web. Cargo auto publish to web. On the Google VM Bash terminal, recreate the container and the pod. Done. It works. On my public IP address I attached the Nginx server. I use it as a reverse proxy. It receives requests on the HTTPS port 443 and then route it internally to my web apps. I have many web apps. Each one is listening on a different port on localhost. If the route starts with webpage hit counter, then the Nginx will processes it and turn it into a localhost 8011 request. After appending lines in the config file, gracefully reload Nginx to read the modified file. Try it in browser. It works like a charm. I already have a hit counter on my web pages. I want to replace it with my project webpage hit counter. I will start with my webpage bestia.dev. It has 273 hits. I will replace the image element. We need to insert the data in the database. Check the bestia.dev page. It shows the hit counter. Refresh it and it is incremented. Fantastic. I can now repeat this for all my other pages. This is all for today. Thank you for watching and see you next time. Feel free to contact me on bestia.dev or GitHub.